Welcome to the Love Letters to Our Bodies podcast. I'm your host, Gwendolyn Mitchell, founder and CEO of Moyo Institute and lifelong spiritual seeker and energy worker. Here for thoughtful conversations about health, healing, and happiness by, for, and about Black and African American women. Disclaimer, the Love Letters to Our Bodies podcast does not provide medical advice. The opinions, experiences, and insights shared are for informational purposes only. Nothing shared in this podcast is intended to be a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of your physician or other healthcare provider. Don't disregard or delay seeking it because of what you've heard on this podcast. Thank you. Are you ready? Let's dive in. Welcome back to Love Letters to Our Bodies. I'm Gwendolyn Mitchell, your host. A few days ago, we explored Histotripsy, this innovative treatment that uses focused sound waves to destroy cancer cells without surgery, without heat or radiation. If you haven't listened to that episode yet, I encourage you to go back and start there. Today, we're diving deeper into one of the most fascinating aspects of histotripsy, something called the abscopal effect. And this is where treating one tumor can actually help your immune system recognize and fight cancer in other parts of the body, places that weren't even directly treated. What makes this so exciting is how it demonstrates the body's inherent wisdom and its capacity to heal itself when given the right support. Histotripsy doesn't just destroy cancer cells. It seems to awaken and educate our immune system in a way that honors the body's natural intelligence. And if you're wondering where you might access this treatment, I've put together an article on Moyo Institute's blog with a list of hospitals and clinics currently offering histotripsy, plus exciting news about the Veteran Administration's plans to make this treatment available at VA hospitals across the nation. You can find that at www.moyoinstitute.org/blog. Let's explore how the abscopal effect works and what it might mean for the future of cancer care.
Welcome back to the deep dive. Today we're jumping into a really fascinating and frankly vital comparison in the future of cancer treatment. We got a fantastic stack of sources from our listeners, and this whole deep dive was actually inspired by some great questions from the Moyo Institute community. They're looking for real clarity on the differences between two therapies. You've got the traditional established approach of radiation therapy, and then this futuristic sounding thing called histotripsy. So our mission is pretty simple, but it's crucial. We want to go way beyond just a surface level description. We need to really dig into the science, compare how these two treatments physically destroy a tumor. And this is the big one, how they each talk to the body's immune system. Because we're not just talking about killing a tumor in one spot anymore. And the hook here, the thing that gets really exciting, is something called the abscopal effect. We're going to unpack how one of these treatments might actually enhance the body's own ability to fight cancer everywhere else. So let's unpack this.
Okay, so to really understand this, we have to start at the very beginning. The fundamental difference in action. Because everything else, the side effects, the precision, that immune response you mentioned, it all comes from this one question. How do they physically destroy tissue?
Right, the basic mechanism.
Exactly. Let's start with the one we all know, radiation therapy. Its method is essentially damage at the molecular level. It's chemical, it's physical. It uses these high energy X-rays to cause, two main kinds of destruction inside a cell.
Okay.
First, there's direct damage. It literally causes what we call double-stranded breaks in the DNA. It just scrambles the cell's blueprint.
Yeah.
Then you have the indirect damage. The X-rays create these highly reactive oxygen species inside the cell, which act like tiny corrosive agents, just tearing up proteins and membranes.
So you're essentially frying the cell from the inside out. You're damaging its DNA so badly it can't function.
That's a great way to put it. It's a molecular wrecking ball. The goal is to cause so much damage that the cell can't repair itself and it just dies off, days or even weeks later.
Okay, a molecular wrecking ball. So then, what is histotripsy? Because that sounds like a completely different world. It's mechanical, right?
Completely different. If radiation is a wrecking ball, histotripsy is more like a sonic jackhammer, a very, very precise one. It uses focused ultrasound waves. But, and this is key, it's not about heat. It doesn't cook the tissue.
Okay, so what is it doing?
When those sound waves converge on the target, they create these microscopic bubbles that rapidly expand and then violently collapse. That phenomenon is called cavitation. And that collapse, that implosion, generates this intense, very localized mechanical pressure. It literally tears the tissue apart. It liquefies the cells.
Wow.
And the crucial part here is that it's all done without heat and, importantly, without any ionizing radiation. It's pure physical force.
So one is molecular frying, the other is mechanical smashing. That is a huge contrast. Yeah. So how does that change the actual experience for a patient, the treatment itself?
Oh, it's night and day. Because histotripsy uses sound waves from outside the body, it's completely non-invasive.
No needles, no incisions.
None. No incisions, no needles. And our sources really emphasize that it's typically a single session treatment. You go in, it's an outpatient procedure, and you go home. Recovery is usually very quick.
That is a massive advantage right there. I mean, compared to the standard of care.
Well, with radiation therapy, it's highly effective, of course.
Yeah.
But it often requires what we call fractionated treatment.
Multiple sessions, sometimes daily, spread out over several weeks. And you need that time to let the healthy surrounding tissue recover from the cumulative radiation dose. But that reliance on radiation means toxicity is always the limiting factor. You're always restricted by how much radiation the nearby healthy organs can safely take. Okay, so let's talk about precision then, because sparing healthy tissue is always the goal. How does histotripsy vibrating tissue to death essentially manage to be so selective? How does it spare, say, a major blood vessel right next to the tumor?
This is where the physics of it is just so elegant. Unlike radiation that kind of hits everything in its path, the mechanical action of cavitation is incredibly focused. The sources are clear on this. It can destroy the soft tumor tissue while leaving more resilient structures, like the fibrous matrix of a blood vessel, completely intact.
That point about blood vessels is a big deal, right? Especially when you compare it to other techniques.
A huge deal. Think about something like thermal ablation, which uses heat. If you try to cook a tumor that's right up against the big blood vessel,
a blood cools it down.
Exactly. The flowing blood acts like a coolant, a heat sink, and it just draws the heat away. It makes a treatment much less effective in those tricky spots. Histotripsy completely sidesteps that problem. Its power is mechanical pressure, not heat. The blood flow doesn't interfere with those bubbles collapsing, so it's just as effective right up to the vessel wall, but without damaging the wall itself.
Here's where it gets really interesting for me and for the patient experience. If it's not thermal and it's not using radiation, what does that mean for all those side effects that patients dread? I mean, the sources seem to suggest that because it's so localized and mechanical, the whole side effect profile just changes. No radiation burns, no hair loss.
Precisely. Those are side effects of ionizing radiation hitting healthy skin and tissue. Histotripsy doesn't do that. And because it's strictly a local treatment, it also avoids those big systemic symptoms you get with chemo or high-dose radiation. The deep fatigue, the nausea.
The general malaise.
Right. The toxicity is confined right to the treated area, which can make a world of difference for the patient's quality of life, literally right after the procedure.
So, okay, we have a non-invasive single-session technique. It's incredibly precise. It has minimal immediate side effects. That's already compelling. But the real game changer, and this is why the Moyo community brought us these sources, is how these different ways of killing a tumor interact with the immune system, specifically with metastatic disease.
Right.
The Love Letters to Our Bodies podcast is sponsored by Moyo Institute Incorporated, a nonprofit organization offering heart-centered educational experiences, and the Lloyd Symington Foundation, which supports visionary grassroots cancer programs.
And that brings us to the abscopal effect. This raises a really important question. What even is this effect? And why is it sort of the holy grail of cancer therapy?
Yeah, define that for us.
So simply put, the abscopal effect is when you treat a primary tumor in one location, and then spontaneously, untreated tumors far away in the body start to shrink or even disappear. It's the proof that your local treatment somehow educated the body's own immune system to go hunt down and attack the cancer everywhere.
That sounds amazing. You treat one spot, the immune system cleans up the rest. So why isn't this happening all the time with the standard therapy like radiation?
Well, that's the thing. Historically, with radiation alone, it's extremely rare. It almost never happens.
Why?
Because even though radiation kills cells and releases some tumor debris, the way it kills them can actually suppress the immune response in that area. Radiation can create what's called an immunosuppressive microenvironment. So the immune cells, the cleanup crew that's supposed to get the signal, they either get overwhelmed or just actively inhibited by what's going on in that irradiated tissue.
It's like you're trying to send out an alarm, but you cut the phone lines at the same time.
That's a perfect analogy, and it's why the standard of care has had to evolve. We only started seeing the abscopal effect more often when we began combining radiation with immune checkpoint inhibitors.
The drugs that basically unclog the fuel lines, so to speak.
Exactly. The radiation releases the signal, and the inhibitors help the immune system actually receive it. And the data in your sources really backs this up. Mouse studies found basically no evidence of T-cell infiltration. Those are your key immune killer cells in distant tumors when they used radiation alone.
Okay, so radiation needs a co-pilot to get this done. What does the research say about histotripsy? Is it triggering this systemic response on its own?
This is where it gets so exciting. The research suggests that, yes, the mechanical action of histotripsy may produce a significantly stronger spontaneous abscopal effect.
All by itself.
All by itself. The same mouse studies showed a really powerful contrast. What's fascinating here is that the histotripsy group had increased levels of antigen-specific CD8 plus T cells, not just in the treated tumor, but in the untreated distant tumors.
And that's the smoking gun.
That's the smoking gun. It's direct evidence that the immune system was successfully trained. It learned the cancer's identity, and it sent out killer T cells to go hunt it down systemically.
Okay, that is the critical finding. So now we have to ask why. Why is smashing the tumor better for the immune system than frying it?
It all comes down to one thing: the preservation of tumor antigens.
The intel.
The intel, exactly. Antigens are the protein markers, the unique molecular signatures on a cancer cell. They're the ID badge that the immune system needs to read to launch a targeted attack.
And histotripsy, by just liquefying the tumor, it releases all that stuff, but leaves the ID badges intact.
Perfectly intact. Because there was no heat, no radiation, the antigens are spared. When that liquefied tumor debris floods the local system, the immune system sees this huge rush of perfectly clear, identifiable targets. It's like a massive alarm bell goes off, initiating a full-scale response.
So the local destruction basically acts as an in situ vaccination event. The dead tumor becomes the lesson plan for the immune system.
That is precisely the concept. Radiation and sheet-based therapies, on the other hand, they tend to denature or fragment those proteins. They cook the ID badge or they shred it. And if the immune system can't get a clear read on the cancer signature, it can't launch that effective targeted attack on distant metastases.
So connecting this to the bigger picture, this is profound. Histotripsy isn't just less invasive or easier on the patient in the short term. Its very mechanism fundamentally changes the entire equation for the immune system.
It's a major paradigm shift. For decades, the goal was just kill the tumor. High efficiency, destroy the primary at all costs. Mm-hmm. But now we're seeing that how you kill the tumor is just as important as if you kill it. You have to do it in a way that maximizes the body's ability to use that debris to fight the cancer everywhere else.
It's this beautiful integration of, high-tech physics and just basic biology. You're using a precise tool to empower the body's own natural defense system.
Absolutely. It's a two-pronged attack. The future is clearly in these kinds of integrated approaches, where the treatment doesn't just destroy, it also supports the patient's own biological machinery.
So what does all this mean for you, the listener? It means the whole field is moving towards therapies that are they're fundamentally different from the methods we've relied on for the last 50 years. The idea that a simple physical action cavitation, this mechanical destruction, could be a more effective immune trigger than high-energy X-rays. I mean, that opens up a massive new direction for research, for how we think about long-term systemic control of cancer. That's a really provocative thought to sit with. Thank you so much for sharing your sources and letting us dive deep into this. We really encourage you to keep exploring these advancements. We'll talk to you next time.
The abscopal effect reminds us of something profound. Our bodies are not just passive recipients of treatment. They're active participants in healing, with an immune system designed to recognize and eliminate threats, including cancer. What histotripsy offers is a partnership with the body's own wisdom. By mechanically breaking down tumors and preserving the antigens our immune system needs to learn from, this treatment creates opportunities for our bodies to do what they were designed to do: protect and heal. As we continue to witness these innovations in cancer care, I'm filled with hope, not just because of the technology itself, but because of what it represents. A shift towards treatments that work with our bodies, not against them. Approaches that honor our wholeness even as they target disease. Thank you for joining me today for this deeper look at histotripsy and the abscopal effect. You can find more information at moyoinstitute.org/blog. If this conversation resonated with you, please share it with someone who might benefit. And remember, you can find all of our episodes, resources, and ways to connect with Moyo Institute at our website. Until next time, keep writing love letters to your body. Your body is listening, learning, and healing in ways that we're only beginning to understand. That's a wrap. Thank you so much for listening to Love Letters to Our Bodies, conversations on health, healing, and happiness. To find out more about the Love Letters to Our Bodies project, visit our website at moyoinstitute.org. That's MOYO Institute.org. Follow us on social media and subscribe to the podcast so you don't miss an episode. If there are topics you'd like for us to discuss, let us know. Remember, your body is beautiful, girlfriend. Love it.